Hi, this is Cash Foley, and I'm going to do a demo on SQL Server Patcher. I'm focusing on the actual execution of it, including really the most important feature it offers, and that is the ability to not only do rollbacks but to have a process that verifies it, so that when it comes time to actually executing a rollback, you'll have high confidence that it'll work. That's really the biggest issue with doing rollbacks. This is all open source. I have it on GitHub, SQL Server Patcher. I'm going to be got a lot of work to do on documentation. This is not quite ready as of the recording of this video. It really is, but all the functions are there, and I'm really wanting to make a quick video to show what it does, because it's pretty exciting. So as far as setting it up, I have a commandlet called initialize SQL Server Patcher. There you tell it the server name, the database, where you want the output files that it generates to go, where the root file for the patches are, and this little script, what it does is basically, if you know PowerShell, get child item is basically a directory. It's saying do a recursive directory looking for only SQL files, and then it's going to pipe that into a commandlet called add SQL patches. So if we go take a look at our working directory, so this is the directory where it's in. This is the folder called patches. Right now shouldn't be anything in output. Patches, if you look at the way these things, this is sort of like the way Roundhouse works or other systems that use patch files, is it uses an alphabetic control of the order at which things will execute. That way you can add additional folders and you can control the order at which they will execute. This is the initial schema. In here I have paired up files that do create. This is the create table, obviously. And the rollback is very similar. This has some protection against data loss, verifying that if it's going to delete a table, that it doesn't actually have data. It's an optional technique that can be used. You can see here it's just basically dropping the constraints, and it's doing all that work that's standard for doing that. The main thing is that whatever is done by create table, the rollback should undo. So functions is probably the simplest one. I have 3 functions I create. The rollback drops those functions. Print statements will be visible in the console. We'll see those when we're executing patches. But the key thing is when you have a patch file, the .sql, the corresponding .rollback file is the one that will actually do the rollbacks. So jumping back over here, if I do a get child item recursive, it's going to find both rollbacks and regulars. The engine pairs them up by the file, and it has the order based on the alphabetic order. So if I initialize this, I'm going to just hit F5, and in here now I'm going to switch to an upper lower pane. It returns, I got in here the actual connection information for the database. If I jump over to SQL Server Management Studio, and if I show here, we see that we don't have any tables at all. Northwind is what I'm working with. It's a standard Microsoft database. I downloaded it here. You can see it has all the tables and whatnot in here. And I'm working from a Visual Studio Microsoft project for helping create patches. Not really going to get into that in this video because of wanting to move through it and show the actual execution. I'll have another video on creating patches and rollback scripts, but I will show it working. So once I initialize, it uses this script to look at that and get the state. I pass it as a parameter so that it can re-execute it at various points in order to get the current state of things. We'll see how that works. So if I say get SQL Server patch info, and now I think it'll look best if I switch over to this view. We can see that it's detected 4 different patches. Each of them have rollbacks, and each are set to execute because they have not been executed yet. If I now go to publish, you can see those print statements, right? All those print statements that were in those SQL statements, they come out echoing out here. And it also echoes each patch as it's doing it. So as a result, all these tables should now be in here. So we can see them there. Obviously views, store procedures, and hello. Okay, so refresh that and you see all of them. A little awkward going back and forth there. I'll show you a trick I have for looking at database objects without jumping back and forth with SQL Management Studio. So I executed those 4 patches. That's my dog. Apparently somebody's coming at the door. And so now you can see that will execute is set to false because it's already been executed. If I show the history, I can see that it has 4 patches have been executed. There's the names. It shows that rollback is available. So if this is what I mentioned also before is SQL Server, get SQL Server Patch DB objects. Now that's a mouthful, so I have aliases for a lot of these things. Show patch history, show patch info, publish patches. Makes it a little bit easier in interactive sessions, though it's a good idea to use the fully qualified names in real scripts. Okay, so if I do this, it shows all the tables, functions, store procedures that got created in there. There's parameters on here, so if you just want to look at the functions, you can see that we have 3 functions. If you want to look at all, not only will it show the tables, but it'll also show constraints, all the objects that are in the meta table. So I find this to be very convenient for being able to go, okay, what's in there? But all of this is real objects that it returns, so you can actually pipe that into variables and actually do your own analysis through scripts if that's what you need to do. Don't know that there will be need, but the ability's there. So back to showing patch history. I see I got 4 patches here. Now I'm going to roll back patch 4. That was the last one here. And if I execute that, you can see it dropped those functions, and that's the end of the script. Again, these are just print statements that are in the script, and then you can see I got a new entry in the table. So what that's about, I'm going to take a quick view over here. So you can see once it executes patches, it creates a patch file folder table. This is what I use for tracking the patches in here. So you can see now it has where the first execution was when I created the functions. Now it's put an entry in there for rollback. I indicate in here which one is the rollback for it. I have a flag for rollback. The same view is here. If I do show patch history, I'm going to do show rollbacks. You can see it has these 5 entries in here, and we can see that this has been rolled back by having an ID here. It indicates which ones did the rollback. This one indicates that it actually executed a rollback. If I just say show patch history, it just shows 3. Well, that's because this is really the current state of things. These are the patches that have been executed, and if we do show patch info, here we can see that this patch is ready to execute again. So if I was to publish, it would ignore the fact that it had been executed and rolled back. It would be prepared to execute it again. It would be possible, of course, to go change the script at this point, change the rollback, and have it be ready to apply again. So it's a great tool for just even developing, right? So if I go publish patches, created my functions back. If I show here, I can see that I got my functions back. Now if I show the history, I got 1, 2, 3. You can see it jumps to 6, and that's because 4 and 5 were rollbacks. Again, if I want to show the full history, that's possible. Oop, wrong line. Selected L. That doesn't help. Okay, so you can see I got 6 entries in here now. two of them were the initial execution and then the rollback, and then finally we got it again. So at this point, the database should match the model. And if I jump over to Visual Studio, and I got a saved comparison here that does that, it's going to compare my database model to it. What I'll do is actually change this. I'm going to have it point to the source database. Kind of running on not always a good idea in demos to wing it, but I just want to show that after executing all that, it all matches, except of course I have my SQL Server patch table that I put in there, which in this comparison I've told it to ignore that. That's why it's not there. So otherwise it's saying you want to delete this because it's not in the source, but of course I really don't care about that, so I'm ignoring it. It's a configuration for this. There's a lot of options here. I'm not going to go into all that in this demo, but it shows that after executing all that, doing a rollback and putting it back, it still matches the model. Now, if I say show patch info, it shows all of them have been executed. If I do publish patches, it's going to do nothing, of course. Now, I've demonstrated rolling back a patch 4, right? Now, if I do show patch history, you can see I've got 1, 2, 3, and 6. If I roll back patch 1, it's going to do everything. So if I do show DB patches, the objects, if I do F8, I got everything in here. I'm going to do a rollback all the way to 1. Now if I do show DB objects, there's nothing in there. So it actually executed all these patches. Now it's rolled back to before there was any objects in here. If I do look at the patch info again, it's going to show that, yep, I got 4 patches that are ready to execute. Now, I'm going to switch views on this so you can see the whole line. So publish patches, you can say, I only want to do a specific one. So like, for example, I've got 4 queued up. I'm going to tell it, create the tables. And so it's only going to execute that one. So it created all the tables. If I show patch info, it says that one's been executed. If I show my patch history, it's going to show only that one got executed. So you can gain control of it if you don't want to just execute all. Most of the time, of course, in automated processes, you're just going to have it execute everything that hasn't been executed. Again, if I show database objects, only the tables are there. So now if I publish patches, it's going to execute the rest of them. Show that. So now we're moving along. We've done 14 patches. Now, I'm going to show one of the best features of this, and that is the ability to not just roll back and replay patches, but to be certain that it's actually doing what it's supposed to do. So I'm going to roll back patch 14. That created that 15. If I say show patch information, notice that only one of them is set to execute. So there is a parameter on show patch info that says just return the ones that are supposed to be executing. So that's that one, right? So if I execute this, only one object's going to come back. It's going to pipe into test SQL Server rollback. Now what this does is a series of steps. First thing it does is it creates a DAC pack of the current state of the database. So that's with these 3 patches executed and this one not, right? So I'm going to create a DAC pack that is a snapshot image of the database objects. I'm going to execute the patch. That's going to create my functions. Now I'm going to create a second DAC pack that shows what it was like after it got executed. Now, the next thing it does is it actually automatically then executes the rollback, and then it compares the DAC pack that we created in step 1 to the current state of the database, and it should match completely, right? So it's going to do that, verify that there's no differences. Then it's going to re-execute the patch. And then at the end of all that, it should be, the current database should match the DAC pack that we created in step 3. I know that's a lot of jumping back and forth, but by doing that, you gain complete certainty that not only is it executing the patch and the rollback, but that the process of doing that is leaving the database in the states that they were supposed to be in. So I'm going to execute that line. And you can see it's creating the DAC pack there. It's executing the patch. It created the second DAC pack. It's dropping the tables. It's then comparing. It already completed, of course, but compares the results after the rollback. It redeploys the patch. Then it compares the end. Everything worked as it was supposed to. So if I show patch history, of course, it now shows that I've executed this one. Now, if I do show patch history with show rollbacks, it's starting to roll up here, lots of them. So it gets a little confusing if you want to really track it. So it shows the full history, and including the backwards and forwards playing. And so at this point, I can say show history. I'm going to get rid of the rollbacks. So you can see I got patch 11 being the first one. Now, if I do that, of course, it's going to show nothing's ready to be executed. If I roll back again, now it's rolled back all the patches all the way back so that there's nothing, and all 4 are ready to be executed again. So a lot of back and forth here. But at this point, what I want to show is that the fact that this has all 4 of these ready to be executed. It's going to pipe that into test SQL Server rollback. And what that's going to do is going to execute that sequence that I showed earlier, all 7 steps, for each patch. So as it goes forward, it's going to execute the patch, it's going to roll it back, verify that it's what it was before, it's going to roll it again, verify, and it's going to move through each of the patches. So it's kind of, again, a wild sequence. So you can see here I've created those DAC packs, I'm doing the rollbacks, I'm comparing them to make sure that everything's matching, and it's going to go through all 4 of these patches, verifying that at the end of the process, each of those scripts are doing what it's supposed to do. And not much more. It's now on functions. And so if you look at my history again, you can see that we've executed 34 patches through all this process. So it really starts adding up. But at the end of it, it still matches what's supposed to be in the model. So there's my patch info. Here's my objects. If I refresh this, I'm still going to end up with no differences. So that is exactly what I'm looking for. So that's the quick pass through of using this to execute patches, execute rollbacks, and do verifying. There's a lot more coming in this, or is already even in it. I already have a lot of this in here. Transaction management, so that it automatically puts transactions on both ends of a patch. Of course, that can be undone so that if some patches can execute in a transaction for various reasons, either functionally or because of the size of the work being done. But by default, you want to be able to have a transaction so that if it fails in the middle, that it will roll back to exactly what it was before, so that you don't have a partial patches. Partial patches are murder. I can have environment-specific scripts by saying in parentheses an environment. So there's a parameter that says, okay, I'm deploying to prod, and in that case, it will execute only scripts that, it will execute the regular scripts, but in addition, it will execute any that are prod. If there's ones that are labeled dev or test, it will skip those. So very powerful, so that you have specific environment settings for whatever you need. Another technique for doing that is token replacement, where you can have tokens that are replaced within the script so that it will do specific things in environments or in particular phases of your deployment. I've got the ability to re-execute scripts when they change. Now, this is really a legacy function that I had in there. I haven't deprecated or got rid of it. It does not really support rollbacks because you need to have the full history of a stored procedure. Usually the way those will work is you'd put these scripts in stored procedures and views and functions, and that way whenever you added it, it would change. When I show how to do patches, it's not a big deal to have it automatically detect what needs, and frankly it does things that are way more powerful than would be done the old way. Dependencies could get you on those things. So overall, I don't recommend this technique, but a lot of people love it, so there it is. Execute every time scripts lets you do things like backups and things like that. This is a cool feature. This is a PowerShell thing. It's a what if execution. It will show you what it would have executed had it been, if you didn't have what if. It would generate the scripts. You can go look at those, and you can even execute them manually if that's where you are in your process towards fully automating. But that's a very powerful feature. In fact, if we jump over here and I go down here and you can see output, you can see here's all the scripts that were executed in this process of doing this. It even has the DAC packs I created. So fully auditable. You got the audit in the table, and you have an audit of the scripts that were executed. Coming soon, I'm going to get this into the PowerShell gallery so it'll be readily available. I'm going to be adding a DSC component. This will play very well with DSC because the key thing with DSC is for it to do nothing if nothing is to change. Well, of course, this is the way it's built. If there's nothing to be published, it does nothing. If there's something that needs to be done, it'll do it. And another big feature that I haven't put in here is the ability to have lookup data. And it doesn't care if it's just for lookups, but that's the typical thing. Things like lookup tables that are going to be drop downs, or maybe rules engines and things like that are really painful to maintain. I'm going to be adding the ability to not only have those lookup tables, but to be able to have rollbacks based on when you do your releases. Very tricky thing to do manually. Anyway, that's it for now.